Hi everybody, welcome to our classroom. It is April 7th. Okay, today we are going to get an introduction to lesson 4. So before we start on lesson 4, there's a couple of things I want to go over with you very quickly about slope. So when we talk about slope, slope is a number. So if I'm asking you what is the slope, your choices are any number in the whole wide world or undefined. If I ask you for the slope, don't tell me positive, negative, zero slope, no slope. Those are types of slope. There are 4 types of slope. Positive, that's going up. Negative, it's going down. No slope, that's when you have no life and it's a vertical line crashing to the ground. And zero slope, that's when it's a horizontal line and you're going 0 miles an hour on that hill. Those are types of slope. If I ask what is the slope, I'm asking for a number, or if it's a vertical line, the answer is undefined. Okay, so keep that in mind about slope. The other thing is we're going to, instead of using the word slope all the time, because it's so long and we are going to want to put slope into some equations. I know that's a little weird right now, but it won't be. We're going to use a variable for slope. So you'd think, okay, well, what makes sense? S, right? Wrong. I don't know if it's because an S looks too much like a 5 or what, but they chose to use, not me, they chose, and it will be for all, ever and always, to use the letter M. M, a small m, means slope. M for slope. Don't know why. Maybe it's because it's hilly and hills are slopey. I don't know. Whatever. Anyways, when I say M, I'm talking about slope. There are 2 other things that we talk about that are the same as slope. One is the constant of proportionality, and the other is the rate of change. Last year we talked about rate of change a little bit. So rate of change, constant proportionality, slope, M, y2 minus y1 over x2 minus x1, rise over run, those are all the same thing. Okay, I know that's a little bit confusing, but just know if they ask you for the constant of proportionality, they're asking you for the slope. They're asking you for the rise over run, or if you only have numbers, you can do y2 minus y1 over x2 minus x1. Okay, so those are some things that I wanted to make sure that you knew about slope before we go on to lesson 4. And lesson 4 is all about y-intercept, and it's super easy. All y-intercept is where the line touches the y-axis. So I'm going to bring you up really close here to my board, and hopefully we don't have too much glare. All right, I don't know, is that clear? Maybe it's just my eyes. Let me put my glasses on and maybe it will look better. Oh, it looks a lot better. All right, if we had this graph right here, this line graph right here, you can see that right here is the point where the line crosses the y-axis. Remember, this is y and this is x, okay? So right here is where it crosses the axis. And what is the name of that point? Well, it's 0. So we put a 0 for the x coordinate, and then it goes up 1, 2, 3, 4. The run is 4. So it's 0, 4. That's where this one touches, right? So we have another one. It looks like this. Down here is where it touches. And we're going to do the x-axis. That's this one. This is our y. And for x, we don't go anywhere. We stay right here. And for y, we go negative 1, 2, 3. So it's 0 for x and negative 3 for y. We have one more. And it's this one. And it's right here is where it touches. We didn't go anywhere. We didn't go anywhere for x or anywhere for y. It's right on the origin. So for our last one, oh, look at that. It's moving all by itself. It's 0, 0. Okay. I want you to look at these 3 points and see what it is that they have in common. Hopefully you noticed that all of them have the x coordinate of 0, right? All of them have an x-coordinate that is 0. So, get rid of that. So all of our y-intercepts, where the where the line crosses the y-axis, all of them, boy, red doesn't like to erase, does it? All of them are 0 for the x-coordinate. Let's do this one again. Okay, so when we are naming our y-intercept, we leave off the x part, and all we do is name it by how far up or down you had to go on the y-axis. So for our first one, we had to go up 4. So the y-intercept for this first one would be 4. For this second one, our y-intercept would be -3. And then for our last one, our y-intercept would be 0. There is a difference between having a y-intercept of 0 and having no y-intercept. 0 is a number, okay? If I had, let me make one real quick here for you. If I had a graph and my line, oh, that's really bad because I didn't use a ruler, but if I had a line that looked like this, oops, forgot I took my thing away. All right, it looks like this. It's straight up and down. Here, put it up close, straight up and down. Is it ever going to come over here and cross this y-axis, even way down low? No, it's never going to get there because it's straight up and down. This has no y-intercept. Not the same thing as 0 y-intercept. 0 is a number. No y-intercept. There's just nothing here. Okay, so every once in a while, you'll get a crazy thing like this. If you get a line like this and they ask you what is the y-intercept, you're like, well, that line doesn't touch the y-axis. Well, yes, it does. Because if you'll remember a thing that you know about lines, these arrows mean it goes on forever. So you would have to figure out where that line would hit the y-axis. How do you do that? Look at the slope. If we look from here, we go up 1 over 1. We could just keep going up 1 over 1 until we hit the y-axis. So we go up 1 over 1, up 1 over 1, up 1 over 1. Of course, I already lost it, so got to do it again. 1 over 1, right? This is so hard to do on camera. Right there is where it would hit if this line was extended as far as we can see it. So it would hit that y-axis there, and it would be -1, -2, -3. This would have a y-intercept of -3. Let's take a look at this one right here. All right. So if this is my x and this is my y, where is that going to hit? Well, let's first figure out our slope. So if we start here and we go up 1, 2, we hit, up 1, 2 over 1, we hit. So it's up 2 over 1, but we have to go backwards. So instead of going up 2 to the right 1, we're going to go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, way down here. And if you can kind of picture that line extending, that's where it would hit the y-axis. You can't just eyeball it though. You have to figure it out using slope. So this would be -1, -2, -3, -4, -5. This would be a y-intercept of -5. Okay. On your lesson 4 paper, you're going to have a couple of definitions. One, y-intercept. It's the point where the line crosses the y-axis, but we just use the y-coordinate to name it. I've already explained that to you. Another word, all right, so remember how I told you for slope we have constant of proportionality and we have rate of change as other ways that we can say slope? Well, y-intercept can also be called initial value. initial value. It's like where something starts. If it started at the at the y-axis, that's where it would start. So initial value is another thing that means same thing. And just like we use the letter M for slope, we're going to use the letter M, and y-intercept, we're going to use a small b. Be careful that you don't make it look like a 6. Make sure your 6's don't look like the small letter b, or you're going to get confused. I think that that's everything. So you should be able to go through and do lesson 4 now. If you have any questions, guess what? Email me. Happy day.